A massive interstellar visitor is hurtling toward our solar system at a staggering 130,000 miles per hour. On the surface, 3I/Atlas appears to be nothing more than an oversized comet. Yet its trajectory tells a different story, one that has left the world's leading scientists questioning everything they thought they knew about natural celestial objects. The path of 3I/Atlas carves an unprecedented arc through our cosmic neighborhood, sweeping past Mars, Earth, Venus, and Jupiter in rapid succession. This precise four-planet flyby sequence has a probability of occurring by pure chance of less than 0.005%. When you factor in its enormous size, unexplained acceleration patterns, and the statistically impossible tour of our planets, some of the brightest minds in astronomy are beginning to ask an unsettling question. Could 3I/Atlas actually be a nuclear-powered reconnaissance spacecraft, deliberately sent to test humanity's ability to detect and respond to extraterrestrial visitors? If this object is engineered rather than natural, the implications are staggering. We may be witnessing humanity's first genuine contact with an alien intelligence, and our response to this discovery could shape the future of our species. But what evidence would finally prove what we're truly dealing with? In July 2025, astronomers begin compiling data that defies conventional explanation. The object cataloged as 3I/Atlas is racing across the solar system at 130,000 miles per hour, a velocity so extreme it could cross the Atlantic Ocean in less than 2 minutes. Its measured diameter of nearly 20 kilometers makes it the largest interstellar visitor ever recorded. To put this in perspective, 3I/Atlas is roughly the length of Manhattan Island, traveling at speeds that dwarf any known comet or asteroid. Astrometric teams at the Rubin Observatory and the Transiting Exoplanet Survey satellite, TESS, meticulously track the object, logging each position with millisecond precision. As they reconstruct its orbit from dozens of high-resolution images, a hyperbolic trajectory emerges, a one-way path through the solar system with no possibility of capture. The object is just passing through, never to return. But something doesn't fit. The orbital calculation shows subtle deviations from the expected gravitational curve. Residuals in the data suggest forces at work beyond simple gravity. Scientists debate the significance of these anomalies. Are they merely noise from measurement uncertainties, or the first tangible hint of propulsion? Standard comet models do predict some non-gravitational acceleration. As sunlight heats the icy surface of a comet, jets of gas burst from its nucleus, creating thrust that can nudge it off its gravitational course. Yet with 3I/Atlas, the coma, the cloud of gas and dust surrounding the nucleus, is surprisingly faint and oddly positioned. There's little evidence of the classic outgassing patterns that define normal cometary behavior. Even stranger is the photometric profile. The object's brightness remains remarkably steady, showing none of the flickering or fading expected as it rotates. There are no telltale spikes or dips from tumbling, no surges driven by asymmetric gas jets. For an object of this size traveling at this speed, any natural process should leave a distinctive signature: thermal recoil from solar heating, irregular volatile jets, rotational variations. Instead, the data reveal an almost mechanical consistency, as the object is maintaining deliberate stability. Escape velocity calculations confirm what the orbital data already suggests. Unless something intervenes to slow it down, 3I/Atlas will never be captured by our sun. Its hyperbolic excess velocity, the speed it retains even after escaping the sun's gravitational influence, ranks among the highest ever measured for any natural object. The absence of a clear natural explanation for this velocity leads some researchers to an uncomfortable question. Could there be an engine hidden beneath that faint coma, deliberately driving this massive object through our solar system? The search for definitive answers pushes astronomers to probe even deeper, dissecting every anomaly in the motion of this Manhattan-sized interloper that refuses to behave like anything they've studied before. By August 2025, the reconstructed orbit of 3I/Atlas reveals something extraordinary. The object traces a path through 4 distinct planetary neighborhoods in less than 6 months: Mars, Earth, Venus, and then Jupiter. Each encounter is plotted within a fraction of an astronomical unit, close enough for Earth's telescopes to capture detailed spectra, yet distant enough to avoid gravitational capture or catastrophic collision. This is not a simple flyby of the inner solar system. It's a multi-planet circuit, each approach calibrated with precision. The object schemes through Mars's orbital lane, sweeps near Earth, swings inside Venus's orbit, and then uses a gravitational slingshot toward Jupiter before departing our solar system forever. Orbital simulations conducted at the Rubin Observatory and by independent research teams worldwide attempt to reproduce this tour using thousands of virtual clones of 3I/Atlas. Even after accounting for measurement errors and possible outgassing effects, the alignment holds true for nearly every plausible version of the orbit. The trajectory threads an incredibly narrow needle, navigating the gravitational influences of multiple planets with apparent ease. The geometry of this path isn't just rare, it's an outlier among outliers. Galactic models built on random stellar ejection and gravitational capture predict that fewer than 1 in 10,000 interstellar objects would naturally stumble into such a chain of close planetary approaches. The Avi Loeb Research Group publishes an even more striking statistical analysis. Less than 0.005% probability for a random visitor to match the specific 4-planet flyby pattern. The claim spreads rapidly through astronomical telegram groups, preprint servers, and conference hallways, igniting fierce debate. Critics argue that the low probability may be inflated by survey bias. Discoveries naturally skew toward objects that pass near the ecliptic plane, where telescopes conduct most of their sweeps. However, even after correcting for these observational biases, the odds remain extraordinarily low. The choreography of this tour raises profound questions. Could this be a reconnaissance sweep deliberately designed to maximize observational vantage points while minimizing risk? Each planet offers a unique window into different aspects of the solar system. The timing and sequence, Mars, then Earth, then Venus, then Jupiter, would favor comprehensive observation without lingering in any gravitational well long enough to be captured or intercepted. The object's path hints at something more than random motion. It suggests intentionality, or at the very least, a pattern that natural astrophysical processes struggle to explain. For planetary scientists, the debate shifts from analyzing physical anomalies to confronting the possibility of purpose behind this visitor's journey. The next question looms larger than ever. If this is reconnaissance, what happens after the observation phase ends? Avi Loeb, the Harvard astrophysicist who previously placed Oumuamua at the center of an intense alien probe debate, steps into the 3I/Atlas controversy with a stark warning. For Loeb, the choreography of this object's path, threading Mars, Earth, Venus, and Jupiter with precision, represents far more than a mathematical fluke. He believes it may be a sign of deliberate reconnaissance by an extraterrestrial intelligence. Loeb points to the probability calculations, less than 1 in 20,000 by his analysis, for a random interstellar visitor to execute such a tour. This figure circulates through research preprints and late-night science podcasts, fueling widespread speculation that 3I/Atlas isn't simply wandering aimlessly through space. It's watching us. The pattern echoes a chilling scenario from theoretical xenobiology and science fiction, the dark forest hypothesis. In this conception of the universe, every advanced civilization represents a potential existential threat to every other. Survival depends on remaining hidden, because revealing your presence to the cosmos risks swift destruction by a more powerful civilization that views you as a competitor for resources or a future threat. If 3I/Atlas is indeed a probe sent by an alien intelligence, the logic of the dark forest suggests that behavior would follow specific patterns. It would scan the solar system from a safe distance, sampling each planet's characteristics, while never straying close enough to be intercepted, disabled, or trapped by our technology. The flybys would maximize data collection, while minimizing exposure to risk. Each approach would be brief, each observation window fleeting, as if the object is systematically gathering intelligence and moving on before any defensive response can be mounted. Loeb's research group draws deliberate parallels to Oumuamua's mysterious 2017 flyby of our solar system. That object's unusual acceleration and tumbling motion sparked similar debates about artificial origins. If Oumuamua was a scout, Loeb suggests, then 3I/Atlas could represent a follow-up mission, a larger, more deliberate probe sent with expanded capabilities. The timing, separated by 8 years, could fit a programmatic cadence of reconnaissance missions launched by a distant civilization. Critics counter that this theory leans too heavily on improbable coincidences and underestimates the impact of selection bias in astronomical discoveries. They argue that with billions of objects traveling through interstellar space, eventually one will trace a path that appears meaningful to human observers seeking patterns. Still, the debate intensifies. Is this a peaceful scientific survey by a curious civilization? A test of humanity's detection capabilities and technological sophistication? Or something more ominous, an intelligence-gathering mission preceding a more direct form of contact? The question remains unresolved as astronomers worldwide weigh the risks of being observed in a universe where maintaining silence might be far safer than broadcasting curiosity. Dr. Rachel Stevenson, a planetary scientist at NASA's Jet Propulsion Laboratory, takes a different view. She surveys the spectroscopic data from 3I/Atlas and finds patterns that tell a familiar story. The coma, though faint and positioned oddly forward the nucleus, contains water vapor, carbon dioxide, and trace organic compounds, the chemical hallmarks of a comet formed in the deep cold of interstellar space, far from any star's warmth. Hubble Space Telescope images reveal a diffuse, sunward-facing haze, but no sharp gas jets or metallic reflections that might indicate artificial structures. Reflectivity measurements across multiple wavelengths match the profile of bright icy grains rather than engineered metal alloys. For Stevenson and most of her colleagues in the planetary science community, the simplest interpretation remains the most likely. 3I/Atlas is a natural object, a comet, albeit an exceptionally rare and oversized wander from interstellar space, not an alien vessel. Spectroscopy teams carefully analyze the chemical composition, measuring an unusually high carbon dioxide to water ratio of approximately 8:1. This ratio ranks among the highest ever recorded and points to an origin in the extreme cold of interstellar space, where carbon dioxide ice can survive intact for millions or even billions of years during the long journey between star systems. Isotopic signatures, while still carrying some uncertainty due to the object's distance, fall within the wide range of values observed in solar system comets and in 2I/Borisov, the previous confirmed interstellar visitor. The coma's brightness, measured across multiple wavelengths as the object approaches and then recedes from the sun, rises and falls in correlation with solar distance, not with any internal power source or pulse that might suggest artificial energy generation. Each new dataset from ground-based telescopes, space observatories, and radio telescopes adds weight to the natural explanation, grounding the debate in established chemistry and physics rather than speculation. The evidence suggests that while 3I/Atlas is certainly unusual, operates according to the same fundamental laws that govern all comets. Yet regardless of whether 3I/Atlas is natural or artificial, the question of how humanity should respond remains urgent and complex. Engineers working on Project Lyra, an initiative focused on intercepting interstellar objects, run detailed simulations. To physically reach 3I/Atlas would require a velocity change, delta V, of at least 60 kilometers per second, a capability that exceeds anything in our current rocket inventory by a significant margin. Light sail designs inspired by the breakthrough Starshot initiative might theoretically achieve the necessary speed, but only with minuscule payloads weighing just grams, and only with years of advanced planning and preparation. The European Space Agency's Comet Interceptor mission currently waits at the Sun-Earth Lagrange Point 2, ready to launch towards slower-moving comets that venture into the inner solar system. However, it lacks the propulsion capacity for a high-speed chase of an object moving as fast as 3I/Atlas. For now, scientific investigation must rely entirely on remote observation through telescopes rather than close-range exploration by spacecraft. We can watch, measure, and analyze, but we cannot touch. Policy advisors at government space agencies worldwide revisit the protocols established under the Outer Space Treaty. The rules are clear. No nation may send unilateral signals to potential extraterrestrial intelligence without international consultation. No nuclear propulsion devices may be deployed in space without proper safeguards and approvals. All significant actions in response to possible contact must be subject to international review and consensus. SETI, the search for extraterrestrial intelligence, and United Nations working groups convene emergency sessions to debate the fundamental question: should humanity attempt to send a message to 3i/Atlas or maintain complete silence? The debate weighs competing risks: the potential benefits of establishing first contact against the existential danger of revealing our location and capabilities to an unknown intelligence that may harbor hostile intentions. The established protocols offer clear guidance: observe meticulously, consult internationally, prepare for multiple scenarios, but take no precipitous action that cannot be reversed. As 3i/Atlas completes its rapid sweep to the inner solar system and accelerates back into interstellar space, it leaves behind more questions than answers. Its 20-kilometer span, 130,000 mile-per-hour velocity, and unprecedented multi-planet flyby, passing Mars, Earth, Venus, and Jupiter within a span of just months, place it among the rarest and most enigmatic solar system visitors ever observed by human astronomers. Despite well-documented non-gravitational acceleration that defies simple explanation, and a tour path with probability by chance of less than 0.005%, spectroscopic data collected by the James Webb Space Telescope and ground-based observatories detected a diffuse coma and high reflectivity values consistent with known cometary behavior. The chemical signatures match what we expect from natural icy bodies formed in interstellar space. Yet profound mysteries remain unsolved. What is the true cause of 3i/Atlas's anomalous motion? Is it merely exotic outgassing from an unusual chemical composition, or something more deliberate? And perhaps most importantly, will similar objects appear in the future, and if so, how frequently? With only a few months of observation before 3i/Atlas recedes beyond the reach of even our most powerful telescopes, the astronomical community must make the most of limited data. Projects like the European Space Agency's Comet Interceptor and the theoretical designs of Project Lyra outline tested strategies for rapid response to future interstellar visitors, whether they prove to be natural wanderers or engineered craft. The appearance of 3i/Atlas represents a watershed moment for humanity. It challenges us to meet the unknown not with fear or reckless speculation, but with rigorous science, international cooperation, and careful preparation for scenarios that until recently belonged only in the realm of science fiction. Perhaps most importantly, it reminds us that we live in a vast cosmos filled with mysteries we are only beginning to explore. Whether 3i/Atlas is a massive comet from the depths of interstellar space or something far more extraordinary, its brief visit through our solar system has expanded our understanding of what's possible and sharpened our ability to detect, analyze, and respond to the unexpected. The data will be analyzed for years to come. Theories will be refined, debated, and tested against new observations. And somewhere in the darkness between the stars, other objects may already be on their way toward our small corner of the galaxy. The question is no longer whether we will encounter interstellar visitors. The question is whether we'll be ready when the next one arrives, and what we'll discover when we finally determine what they truly are. It begins as a whisper in the data, so faint that 3 separate radio telescope arrays dismiss it as interference. But Dr. Sarah Chan at the Very Large Array in New Mexico notices something peculiar. As 3i/Atlas passes Jupiter's orbit on its way out of the solar system, a brief radio emission spikes across multiple frequencies simultaneously. The burst lasts exactly 1.420 gigahertz, the hydrogen line, the universal frequency that any technologically advanced civilization would recognize. Within hours, the signal repeats, not from 3i/Atlas itself, but from a point in space 0.3 astronomical units behind it. There's something else out there. Chen's voice trembles during the emergency teleconference with NASA, ESA, and SETI officials. 3i/Atlas wasn't alone. It was never alone. The follow-up observations are frantic. The Atacama Large Millimeter Array in Chile swivels to the coordinates. The James Webb Space Telescope interrupts its scheduled observations. What they find defies every expectation. A second object, significantly smaller than 3i/Atlas, perhaps 2 kilometers across, matching its trajectory precisely but maintaining a calculated distance. This object shows no coma, no outgassing, no ice. Its radar returns are sharp and geometric, with edges that suggest manufactured surfaces rather than natural accretion. The spectroscopic signature contains no water, no carbon dioxide, no organics. Instead, readings show anomalous absorption lines that some scientists tentatively identify as industrial metals, titanium, aluminum, refined alloys that shouldn't exist in nature with such purity. It's a shepherd. Avi Loeb declares in an emergency press conference that draws 800 million viewers worldwide. 3I/Atlas was the decoy, a modified comet designed to look natural enough to avoid panic. The second object is the actual reconnaissance platform. It's been observing us while we observed what we thought was the only visitor. The implications cascade like dominoes. If 3I/Atlas was deliberately modified to appear natural, then an intelligence capable of such engineering could already be millennia ahead of human technology. If they wanted to hide a true probe behind a false comet, what else might they be hiding? November 18th, 2025, 3:47 Universal Time Coordinated. The second object does something that silences every skeptic. It changes course. Not dramatically. The delta V is modest, perhaps 200 meters per second, but it's deliberate, calculated, and completely impossible for any natural object. The burn lasts exactly 47 seconds, detected as a thermal spike by infrared observatories. When it ends, the object's new trajectory no longer follows 3I/Atlas out of the solar system. It's heading toward Earth. Estimated arrival in Earth's orbital vicinity, 14 days. The JPL announcement states with clinical precision, though everyone reading it feels their blood run cold. The object will achieve a stable position at Earth-Moon Lagrange point 4, maintaining constant distance from both bodies. Intent unknown. Threat assessment inconclusive. The world transforms overnight. Stock markets crash, then rebound wildly as defense contractors surge. Religious leaders offer prayers and prophecies. Governments activate emergency protocols written decades ago and never tested. The United Nations Security Council convenes in permanent session. But Avi Loeb sees something others miss. Look at the trajectory refinement. He tells a closed session of International Space Agency directors. It's not an attack vector. The object is positioning itself in a stable orbit, not an impact trajectory. If they wanted to harm us, a 20-kilometer object traveling at 130,000 miles per hour would be an extinction-level kinetic weapon. They wouldn't need this smaller craft at all. Dr. Stevenson from JPL adds her analysis. 3I/Atlas completed its flyby tour and is now leaving the solar system on schedule, exactly as predicted. It's almost as if it finished its mission, gathering data from 4 planets, and now the second object is waiting. Waiting for what? Someone asks. For us, Chin suggests quietly, waiting to see what we do next. The debate that follows is the most consequential in human history. Do we attempt communication? Do we send a spacecraft to rendezvous with the object at L4? Do we remain silent and observe from a distance? Project Lyra's engineers work around the clock, redesigning their interception mission for a stationary target instead of a hyperbolic flight path. We can reach L4 in 8 months with a modified Dragon capsule and a SpaceX Starship booster. The mission director reports, but we be sending 3 astronauts on a one-way trip to meet something we don't understand. They'd have enough life support for 2 years, but no guarantee of return. The call for volunteers draws 2.7 million applications in 72 hours. SETI works with linguists, mathematicians, and computer scientists to construct a message, a sequence of prime numbers, representations of Earth's position in the galaxy, fundamental physics constants, and a simple greeting. But disagreement fractures the effort. Some argue any message is too dangerous. Others insist that silence will be interpreted as either hostility or primitiveness. China, the United States, Russia, the European Union, India, and Japan engage in tense negotiations. For the first time in decades, geopolitical rivals must collaborate on a decision that transcends national interest. The stakes are too high for competition. Meanwhile, amateur astronomers worldwide train their telescopes on the approaching object. A teenager in South Africa captures an image that goes viral. Against the star field, the object's surface shows a pattern of lights, rhythmically pulsing in sequences of 7. 7 pulses, a pause, then 7 again, the prime number, mathematics as universal language. They're trying to communicate, Dr. Chen realizes. They've been trying since they arrived. We just weren't listening carefully enough. The object settles into position at Lagrange point 4, exactly as predicted. It maintains station 150,000 kilometers from Earth, close enough for detailed observation, but far enough to seem non-threatening. Every major telescope on the planet and in orbit focuses on this 2-kilometer craft that has captured humanity's absolute attention. Then it speaks, not with radio waves or laser pulses, but with something far more profound. The object surface, which had appeared dark and metallic, suddenly illuminates with a holographic projection visible from Earth. The image is crude, pixelated, constrained by whatever technology is translating across the vast gap between civilizations. But the intent is unmistakable. It shows Earth. Then it shows 3i/Atlas's trajectory through the solar system, with each planetary flyby marked. Then it shows a map, a stellar map, with our sun marked clearly and a line extending outward to another star system 47 light-years distant. The star is labeled with a symbol no human has ever seen, but the meaning is clear. Origin point. The projection continues. It shows not conquest, not invasion, but something unexpected. A sequence of other solar systems, dozens of them, each marked with similar trajectory lines. 3i/Atlas and its shepherd craft aren't here to claim Earth. They're surveyors, explorers, mappers of inhabited star systems. We are not alone, and apparently we never were. The final image in the projection is an invitation, coordinates for where to send our response, and a simple visual equation showing how to construct a long-range communications relay. They're not staying, but they're offering us a chance to join a conversation that's been happening across the galaxy for millennia. As the message ends, the object pulses 7 times. The prime number greeting then goes dark again, waiting. In a joint address broadcast, every nation on Earth, the Secretary General of the United Nations stands before the General Assembly. Behind her, representatives from every spacefaring nation and dozens of non-governmental scientific organizations stand united. Humanity has been given a gift today, she begins. Not the gift of technology, or the answer to whether we're alone in the universe. Those answers we must still earn ourselves. The gift we received is knowledge. Knowledge that we are part of something larger and that the universe is waiting for us to be ready. We will send our response, not as divided nations, but as one species taking its first step into a broader cosmic community. We will accept this invitation to communicate, to learn and to grow, but we will do so carefully, thoughtfully, and together. Construction begins immediately on humanity's first interstellar communications array, built with unprecedented international cooperation. The message we'll send is still being debated, drafted, and refined, but everyone agrees on how it should begin. 7 pulses, a prime number, the universal greeting that says, "We understand. We're here. We're listening." On the edge of the solar system, 3i/Atlas continues its journey into the vast dark between stars, carrying data about Earth, Mars, Venus, and Jupiter back to whatever civilization sent it. In stable orbit at L4, the shepherd craft waits patiently, a bridge between worlds, proof that the universe is far stranger and more wonderful than we ever imagined. The age of isolation is over. The age of contact has begun. And somewhere 47 light-years away, someone or something is waiting for our reply. Dr. Sarah Chun hadn't slept in 30 hours. The message humanity would send, its first deliberate communication to an extraterrestrial intelligence, was nearly complete. Representatives from 147 nations had contributed to its construction. Mathematical principles, biological data about Earth's biodiversity, cultural artifacts encoded in universal symbolic language, and most importantly, questions. Humanity had so many questions. But as Chin reviewed the transmission protocols one final time, something nagged at her. The shepherd craft had been silent since its initial holographic message. Completely silent. It simply waited at L4, maintaining perfect station, its surface dark and reflective like a mirror catching starlight. "We're ready to transmit," the communications director announced. The newly constructed Deep Space Network Array, built in record time through unprecedented global cooperation, hummed with stored energy, ready to send humanity's message toward the coordinates the Shepard craft had provided. Chen's hand hovered over the authorization panel. Something felt wrong. "Wait," she said suddenly. "Pull up the spectroscopic data from 3I/Atlas again. The readings from when it passed Jupiter. Sarah, we've been over this 100 times. Humor me." The data materialized on her screen. She cross-referenced it with the Shepard craft trajectory, then with the holographic projection timings. Her fingers moved faster, pulling up orbital mechanics, signal propagation delays, light speed calculations. Then she saw it. "Oh my God," she whispered. "It's not waiting for our response. It's waiting for 3I/Atlas." The emergency session convened within minutes. Every major space agency director, every world leader with access to the secure quantum communication network, all of them staring at Chen's analysis displayed across their screens. "The Shepard craft position at Alpha isn't random," Chen explained, her voice steady despite her racing heart. And the holographic message wasn't just an invitation. It was a test parameter. She brought up a complex orbital diagram. 3I/Atlas is 47 astronomical units away now, still traveling at 130,000 miles per hour. At that speed, with its current trajectory, it will cross the heliopause, the boundary where the sun's influence ends, in approximately, she checked her calculations, 14 days. "I don't understand," the UN Secretary General said. "What does that have to do with?" "Everything," Avi Loeb interrupted, understanding flooding his features. "The Shepard craft isn't here to receive our message. It's here to observe our behavior during a specific window. It's measuring us." Dr. Stevenson from JPL picked up the thread. "The holographic projection showed us dozens of other solar systems they've surveyed, but it didn't show us which civilizations responded or how. It was deliberately vague. Because they're testing whether we can figure out ourselves." Chin finished. "The real question isn't whether we'll send a message. It's what we do when we realize we're being evaluated." A terrible silence fell across the conference. "Evaluated for what?" someone finally asked. Chin pulled up another display, the strange 7-pulse signal pattern the Shepard craft had transmitted. She ran it through every decryption algorithm humanity possessed. Nothing. Then she tried something different. She treated it not as a message, but as a coordinate system, a timing mechanism. The pattern resolved into a countdown. "They're not counting down to when they expect our response," she said quietly. "They're counting down to when they'll act based on what we've already shown them." The display updated. The countdown read, 13 days, 7 hours, 22 minutes. "Act how?" the Secretary General demanded. "Are we in danger?" "I don't think so," Loeb said slowly. "At least, not immediate physical danger. But think about what they've observed so far. They sent 3I/Atlas through our solar system, a 20-kilometer object that could have devastated any planet it struck. We detected it, tracked it, debated it, but we never once tried to destroy it or deflect it. That says something about us." "Then the Shepard craft revealed itself," Stevenson continued. "It performed an impossible maneuver, openly displaying advanced propulsion technology. It came directly toward Earth. And what did we do?" "We didn't attack," Chin said. "We didn't panic. We tried to communicate." "Exactly. Every action they've taken has been designed to provoke specific responses. They're not just gathering data about our planets or our technology. They're measuring our collective psychology, our decision-making under pressure, our capacity for cooperation versus conflict." The Russian Space Agency director spoke up, his voice grim. "And the countdown? What happens when it reaches 0? Chen's analysis updated with new data from long-range telescopes. Her face went pale. 3I/Atlas isn't leaving the solar system," she said. "Look at these micro-corrections in its trajectory. They're subtle, but they're there. It's going to slingshot around a gravitational equilibrium point at the heliopause and... oh no! And what?" Multiple voices demanded simultaneously. "It's coming back. 3I/Atlas is going to return to the inner solar system. And based on these calculations, its new trajectory will bring it within 0.02 astronomical units of Earth. That's 8 times closer than Venus ever gets. The implications crashed over everyone like a tsunami.